Hi everybody. Today we're going to look at unit K142A and we're going to look at activity 1 on page 31 to 38 in the resource book. Now the whole idea of this activity is to measure light output and light efficiency, and the reason we do that is to figure out which light will be the best suited to be used in a certain condition to give the best light luminance and also to give the best efficiency or value for money. So the way we do this is we have to measure the output of a light, and the output of a light is measured in lumens, but that's not really great for what we're trying to do. So we want to measure the lumens on a particular point, so we use lumens per meter squared, or lux, and this gives us a reading of light falling on a specific point. And if we do that for all the lights and also measure the energy consumed by each light, we can compare them to each other and figure out which is the most efficient, therefore which is the most suitable for the application that's required. So first off, we have to look at our different types of lights we have here, which are written on each of these lights here. We have to figure out what the rated input power is first. The rated input power is what the rating of the globe or the particular fitting is. This will give us a rough idea how much energy is going to be used by the light, but it's not accurate. So we also have to use our watt meter here to figure out exactly how much energy is being used by that light. Then if we find out what the background light level is, find out what the light level is with the light turned on, we can then figure out how efficient this particular light is versus another light. So to measure the background level first, I'm actually going to turn down the light that's on here. I'm going to move my light meter here and put it on my stand. I'm going to move it into position. And I'm now taking a reading, making sure I'm not casting a shadow onto the sensor of the light meter. The value I'm getting on the light meter is 93.3 lux, and I'm going to write that into my table in column number 3. Now I'm going to turn my first light on, and it's a 4-watt LED globe, so I expect it to have quite a good light output, so for how much energy it's consuming. So I'm going to stand back, making sure I'm not casting a shadow onto the light sensor, and take a reading now of 131.4 lux, and I'm going to fill that into my table. Now what I need to do is check my watt meter to see how much energy the 4-watt LED is using. And even though it's rated at 4 watts, it's actually consuming 4.35 watts. So a little bit more. This is why we have to do the power reading of the watt meter, not just go off the rated power. Now that I've completed my reading, I can turn back on my overhead light here, and I've got to do some calculations. If I take away the background light level from the light level with the light on, I can now find out how much lux the light itself is producing. So I know that this 4-watt LED now is producing 38.1 lux. Now, the most important part is to find out how efficient this is. So if I take the 38.1 lux and divide it by 4.35 watts, I can find out how much light it's putting out per single unit of watt. So the 4 watt LED globe is producing 8.75 lux per single watt of energy. So if I continue this on for all the different lights on my light table, I can look at which is the most energy efficient all the way through. Now, having completed all my tests, I can now look at which are the most efficient. So I can tell which ones are the most efficient by which has the highest lux per watt. So the highest light output per watt of energy used. Now we're looking at a level playing field and seeing which ones are the most efficient. So the most efficient one is going to be the 12 watt LED. It produces 47.33 lux per watt of energy. The least efficient is going to be the 60 watt incandescent light globe at 1.6 lux per watt. So a huge difference. So 40 times more efficient is the LED than the incandescent. That's why in these days people aren't using old style light bulbs. We've moved to LEDs. So the reason, one of the main reasons the incandescent light is so inefficient is that it's purely resistive. It's a nichrome wire wound around and it just produces heat to create light. That heat causes losses and that's why it's so inefficient. So I hope this unit has been illuminating for you and I'll see you next time. Thanks.